Okay, here we go. And pronto. So I guess the idea is to make sure that you remember all the steps when you're doing the spirals. Okay, and if you don't watch the video, so hopefully you remember as long as I do them correctly as well. So let's this one. Two is different than one because two is more just the algorithm. Okay, so find the GCF between 24, 64, and 72. I think one of the easiest ways we've proven is the ladder method. 24, 64, 72. Pick a number. 8, I think, might work. 8 goes in 24, 3. 8 goes to 64, 8 times. 8 goes to 72, 9. Careful here, because this is a GCF problem. And in GCF, the ladder, I know you can say that we can continue with a 3 and 9, but because it's GCF, we need it to continue with all 3. And since that cannot happen, our answer is 8. The biggest number that can go into 24, 64, and 72 is just 8. Okay, be careful. All right, so I'm going to take those same numbers at the bottom, 24, 64, 72, and we're going to do LCM. Well, let's start with our 8. That's 3, that's 8, and our 9. And we can continue because it's LCM as long as we continue with 2, we are going to. So 3 goes to 3 once, 3 does not go into 8, so repeat that number, and 3 goes to 9 3 times. And now, definitely, we can't continue with any 2 numbers, so let's just circle. And that makes sort of like an L, and we're going to multiply those numbers. So the LCM of 24, 64, 72 is 8 times 3 times 8 times 3. So that's 24 times 24, and I have no idea what that is. So let's do 24 times 24, 16, 96. 2 times, move 1 over. 2 times 4 is 8. 2 times 2 is 4. And 6, 7, 576. So the first number, that's 24, 64, and 72, can all 3 of them can go into is 576. Okay. And in this case, on top here, the GCF is 8, which means that the greatest number that is that can go into 8, 24, 64, and 72 is 8. Okay. A walk down memory lane. Find the prime factorization 288 and write exponential form. Let me just bring this down a little bit more. So you got 288 prime factorization. Let's see. I'll do the easy one. 2 is always easy. 144. 2's prime, circle. 144. You can do 2 again or 12 and 12 because that's 144. 12 is 2 and 6. Circle the 2. 6 is 2 and 3. Circle, circle because they're all prime. So 12 on this side is going to be a repeat of what we just did. So the prime factorization of 288 is 1, let's see, 1, 2, 3, 4, 5 2's. 4, 5, and 1, 2, 2 3's. 2 times 2 is 4, times 2 is 8, times 2 is 16, 16 times 2 is 32, and 3 times c over here is 9. So 9 times 2 is 18, goes 1, 9 times 3 is 27, plus 1 is 28. Look, we ended up back to our original number. So in exponential form, that would be 2 to the 5th power times 3 to the 2nd, and that's our final answer. Okay. Exponential form, to expand it, which means expanded 2 times 3 times 4, 5, 6, 7, 8, 9. 9 times, we're multiplying the base number times itself. 9 times 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is the standard? What is actually the value of this? Well, 2, 4, 8, 16, 32, 64, 128, 256, and 256 times 2 is 512. On this side, the exponential form, 5, there's 5 multiplied by itself 1, 2, 3, 4, 5 times. And 5 times 5 times 5 times 5 is a very big number, which I have no idea what it is. So because I am at home, 5 times 5, 3, 4, 5 is 3,125. Hopefully I did that correct. Okay. Over here, what is 1,000? Let's see. I think I messed up on that one. Not 1,000. Is there a number that equals by 1,000? It's 1,000. No, 40. No, there isn't. So this one, nope, no number, because 10 times 10 is 100, and 100 times 100 is 10,000. Okay, and this is 1,000, so no number by itself, multiplied by itself. So this one I made a mistake. There is no number out there that multiplied by itself, however many times, gives you 1,000. Okay, so that, leave it blank. Okay. Let's go down. Use a distributed property. Okay, remember, distributed property, you're multiplying the number outside by everybody inside. So 7 times 12, and then multiply by 7 times 5. 7 times 12, so let's just write it out first. Multiply these two. Then you're going to subtract by 7 times 5. So there's your equivalent expression. So this is exactly the same as that. If you want to continue, you got 84 minus 35. And 84 minus 35, let's see, carry the 1, 49. Okay, so here is what I was looking for. Create an equivalent expression. So this is definitely the same thing as that. If you continue, you get 49. Factor out. So what was this before? So this is reverse. So let's look for a number that multiplied gives us 32. And that number multiplied again by something inside here gives you 48. So you can do the ladder method for this to factor out, to find that biggest number. Try 2. 16 to 48 is 24. I can use 4. 4 is 16. 4 and 24 is 6. I can use 2 again. 2 and 2, 2 and 3. And our GCF, these three numbers, the side numbers. 2 times 4 is 8. Times 2 is 16. So, times 16. And these two numbers go inside. Let's see. 16 times 2, it is 32. 16 times 3, it is 48. Not bad. Okay, and there are other answers, but 16 is the one that's the biggest number out there. Okay, that can go outside. Okay, and second page, what is 3 and 1/4 divided by 1 1/2? So 3 and 1/4 divided by 1 and 1/2. I'm going to change this to improper fractions. Times plus 13 over 4. 2 times 1 is 2, plus 1 is 3, 3 halves. They don't have same denominator, so let's find the same denominator. In this case, it's 4. This one's already a 4, leave it alone. This one changed to a 4, multiply by 2, multiply the top by 2, and you get 6. Cross, cross, you get 13 over 6. And that's the same thing, and 13 divided by 6, so 6 goes to 13 2 times. 1 left over, 6. Final answer. Stan drove 432.5 miles, 7.5 hours. How many miles did he drive per hour? Okay, so I know the total, and I know the total number of hours. So this is a division problem. 432.5 divided by 7.5. Now move this one over, or multiply by 10, so that gives us 75. And multiply the 10 on the outside, multiply the inside times 10, and move it again, so that becomes 4,325. Okay, so 75 goes into 40, 42, 150, 350, 425. 4 times what? 150 is 2, 225 is 3, 300 is 4, 6 times. No, not 6 times, 5 times. 636. Let's say 5 times. Yeah, 5 times. I think 6 is too much. 5 times 5 is 25. Goes 2. 5 times 7, 35. Plus 2, 37. Subtract. Well, let's see. This borrows here. That becomes a 3. That becomes a 13, which becomes a 12. That becomes 12. 5. 12 minus 7 is 5. That's a 0 over there. 555. Let's see. Ooh, so 75 times, let's see, no, times 8, no, times 7. Maybe times 7. Yep, times 7 works. which is 525. Subtract the 0, that's 3. Okay, we can continue. Add a decimal. Bring 0, bring the decimal up. Bring that 0. 75 going to 300. Well, 75 plus 75 is 150, plus 175 to 25, and that is 4 times. That gives us 300, and no remainder. Beautiful. So 432.5 in 7.5 hours. So that means that every hour that he was out there, so in 1 hour, he did 57.4 miles. Okay. This one is in 1 kilogram is approximately 2.2 pounds. Find your weight in kilograms. Okay, so last time I weighed myself, I'm not too proud of this, but it was about 100. Fine, let's make it 170 pounds in pounds. Okay, so pounds. The rest of the world uses kilograms, so I'd be very heavy if I used 107 kilograms. So 170 pounds, if I want to find how much I am in kilograms, I can just divide 170 divided by 2.2 pounds. That's going to give me my weight in kilograms. Move one over, multiply by 10, so I get, let me clean that up, 22. Move one over, there's no decimal, move one over, so I get 1,700 inside. And let me erase this. Oh, I don't need to erase. Okay, so 22 does not go into 1, does not go into 17, goes into 170, 5, 6, 7, 8, 16, not 8, 7 times. 7 times 2 is 14, goes 1, 7 times 2 is 14, plus 1, 54. Subtract, that gives me 16, bring a 0 down, bring that 0 down. And that's going to be another 7. Wow, my 77 kilos? No way. 154. Now I'm going to subtract, and that gives me 60. I'm going to add a 0 here, add a decimal here, sorry. Then allows me to bring a 0 down. And 22 goes into 60, not 3 times, because that would be 66, but 2 times. And that's 44, 16. I'm going to stop there, because I don't want to know anything else. My weight in kilograms is 77.2 kilograms. Somebody needs to go on a diet. Okay, all right. So, no more chips. Ate 20 chips. All right, next one. What sets? Okay, what sets? -1, it's not a counting number. It's not a whole number, but it's definitely an integer. And it's also rational. -7 or 8, it's not a counting, it's not a whole, it's not an integer, but it's a fraction, which makes it a rational number. It's also decimal, which also makes it a rational number. 999, it's a counting, or you want to call it natural, that's okay. It's also a whole number. It's also an integer. And it's also a rational number, because it's, if you put it over 1, it becomes a fraction. And if you put a dot here with a 0, 0, it becomes a decimal, so it makes it a rational number. I think it's the last one. Put this on the number line, yay. So hopefully all those number lines we did come in handy. So let's see, these are all negative, so I don't need, so I can do this. Now 0, and let me just make it, because I don't need positive numbers. I don't think so. All right, so I'm going to make this a 1, -1. I make this one a -2, and this one a -3. I put an arrow here to continue, and an arrow here to continue. -1.4. -1.4. Okay, and you know what? I'm going to actually, just in case, extend this positive side. 1, 2, -1, not -1, +1, +2. So let's pretend I didn't know where -1.4 was. Well, I do know where +1.4 is. +1.4, it's between 1 and 2. Not too close to 1, but a little bit less than half. So over here. So -1.4, which is this number over here, it being the same location, but just on the other side, between -1, -2, closer to -1, but a little bit over here. Notice that this and this is exactly the same. -0.01. Okay, so on the positive side, and I know I didn't ask you, not asking you to positive, but that's 1 penny. 1 penny is right here, right after 0. So -1 penny should be on the other side and exactly a mirror image. There's my -0.1. -2/5. Well, -2/5, and I gave you that sheet today, so you have to memorize. So 2/5 as a decimal is 0.6 or 0.60, better yet, 60 cents. So 60 cents is a little bit more than half than 1. So 60 cents on the positive side would be about here. Not close to 0, but close to 1, but a little bit more than half. So see, here's a 60 cents positive. The negative should be the same way, between 0 and 1, but on the negative, but a little bit more than half. Here's my -60. -0.099. -0.99 is on the positive. That was 0.99. Very, very close to $1. Very close. Still between 0 and 1. So -0.99 is going to be between 0 and 1, but not here. This is between 0 and 1. Very, very close to -1. 7/8. Okay, now 7/8 is 7/8, the actual 7/8. It's between 0 and 1. Okay, so again, if you're not comfortable with that, you can just go ahead and find what the conversion is. 7/8 as a decimal is rounded to 0.875. That's about, so if you round it to money, it's about 88 cents. So you'd be between 0 and 1, 0 and 1, close to 1, but obviously less than 99 cents. So I'm going to put it over here, 0.88. So this would be the same thing between 0 and 1, close to that, and definitely over here. Okay. -2.99. Okay, not going to do -2.99 is between, so if that was a positive, now make a 3 right here. 2.99 would be very close to 3, just before 3, 2.99, right? Very close to 3. So on the negative side would be between 2 and 3 again, but not here, but very close to 3, but not passing 3. -2.99. And last one, 0.1 or 0.10 is definitely bigger than 0.01. On the positive side, 10 cents would be about here. And its negative counterparts can be exactly on the other side of 0. 0.10. Okay, so that was spiral 2.